Florida, the land of sunshine, beaches, and theme parks. It's a place where people come to escape the cold, embrace the warmth, and create lasting memories. But behind this idyllic facade lies a hidden truth, a meteorological menace that often gets overlooked amidst the allure of paradise: tornadoes. Florida, despite its sunny reputation, has a surprisingly active tornado season. This isn't Kansas, and it's not the Midwest. This is Florida, a state renowned for its tropical climate and laid-back lifestyle. Yet, the same forces of nature that spawn twisters in America's heartland also make their presence known in the Sunshine State, albeit with a unique Floridian twist. The juxtaposition of Florida's carefree image and the very real threat of tornadoes is stark, but it's a reality that residents and visitors alike must acknowledge. Understanding this hidden danger is the first step towards preparedness and ultimately survival. There's a common misconception that Florida is immune to the wrath of tornadoes. This couldn't be further from the truth. The reality is that Florida experiences a significant number of tornadoes every year, more so than many other states traditionally associated with these powerful storms. The myth of Florida's tornado immunity likely stems from a few factors. Firstly, the state's tornado season differs from the well-publicized Tornado Alley season in the spring. Florida's peak tornado activity coincides with the hurricane season from June to November. Secondly, Florida's tornadoes tend to be weaker and smaller than their Midwest counterparts, often lost in the shuffle of hurricane coverage. However, weaker doesn't mean harmless. These tornadoes can still pack a punch, capable of causing significant damage, injuries, and even fatalities. The misconception of Florida's tornado immunity is a dangerous one, leading to complacency and a lack of preparedness. While Tornado Alley might be the more familiar term, a significant portion of the southeastern United States, including Florida, falls under the ominous umbrella of Dixie Alley. This lesser-known region is equally, if not more, susceptible to the devastating impacts of tornadoes. The term Dixie Alley was coined to describe this area, which has a history of severe weather events that rivaled those of Tornado Alley. This region, stretching from East Texas eastward to Florida and northward to Illinois, experiences a unique set of atmospheric conditions that are conducive to tornado development. The geographical diversity of Dixie Alley, from the flat plains of Texas to the coastal regions of Florida, contributes to the complexity of its weather patterns. These conditions create a perfect storm for tornado formation, making it a hotspot for meteorologists and storm chasers alike. Dixie Alley tornadoes often form under different circumstances than their Tornado Alley counterparts. While Tornado Alley tornadoes are typically associated with dry line boundaries and significant wind shear, Dixie Alley tornadoes are more likely to develop in environments with higher humidity and less pronounced wind shear. This difference in atmospheric conditions means that tornadoes in Dixie Alley can be more unpredictable and harder to forecast. They tend to occur in more humid environments with less wind shear but ample instability in the atmosphere. The high humidity levels in Dixie Alley contribute to the formation of powerful thunderstorms, which can quickly escalate into tornado-producing supercells. This atmospheric instability is a key factor in the development of severe weather in the region. These conditions are ripe for the formation of supercell thunderstorms, the breeding ground for tornadoes. Supercells are a type of thunderstorm characterized by a rotating updraft, known as a mesocyclone. This rotation is crucial for the development of tornadoes, and Dixie Alley's atmospheric conditions are particularly favorable for supercell formation. Storm chasers often flock to this region to study these powerful storms and gather data to improve tornado prediction models. Florida, situated at the southeastern edge of Dixie Alley, is directly in the line of fire. The state's peninsular geography means that it is surrounded by warm, moist air from the Gulf of Mexico and the Atlantic Ocean, which fuels the development of severe weather. This makes Florida particularly susceptible to tornadoes, especially during the spring and early summer months, when conditions are most favorable. The state's unique geography, combined with its location within this tornado-prone region, makes it particularly vulnerable to these powerful storms. Florida's flat terrain offers little resistance to the formation and movement of tornadoes, allowing them to travel long distances and cause widespread damage. The state's dense population and extensive infrastructure also mean that the impact of tornadoes can be particularly devastating. Understanding the dynamics of Dixie Alley is crucial for comprehending Florida's tornado risk. By studying the unique atmospheric conditions and geographical features of this region, meteorologists can develop better forecasting models and improve early warning systems. This knowledge is essential for preparing communities and mitigating the impact of these powerful storms. As climate change continues to influence weather patterns, the importance of understanding and adapting to the risks posed by Dixie Alley tornadoes becomes even more critical. Section 4. When land meets sea. Florida's volatile climate. Florida, known for its beautiful beaches and sunny weather, is also a region of extreme and unpredictable weather patterns. The state's unique geographical position plays a significant role in shaping its climate. Florida's peninsula juts out into the Atlantic Ocean and the Gulf of Mexico, creating a unique geographical situation that significantly influences its weather patterns. This dual exposure to two major bodies of water means that Florida is constantly under the influence of maritime weather systems. This is where land meets sea, a constant battleground between contrasting air masses and temperatures. The warm waters of the Gulf and the Atlantic provide a continuous supply of moisture, which, when combined with the heat of the sun, leads to the frequent formation of clouds and storms. This clash of elements creates a volatile atmospheric cocktail, ripe for the formation of severe weather, including tornadoes. The interaction between warm, moist air and cooler, drier air can lead to the development of powerful thunderstorms, which are often accompanied by lightning, heavy rain, and strong winds. The warm, moist air flowing northward from the Gulf of Mexico collides with cooler, drier air masses pushing down from the north. This collision zone is a hotbed for weather activity, as the differing air masses struggle for dominance. This convergence zone, often marked by sharp temperature gradients and shifting wind patterns, becomes a breeding ground for thunderstorms. The rapid changes in temperature and humidity can lead to the development of severe weather systems in a matter of hours. Add in the influence of sea breezes, which further enhance moisture convergence, and you have all the ingredients for a volatile weather day in Florida. Sea breezes, which occur when the land heats up faster than the water, can push moist air inland, leading to the formation of afternoon thunderstorms. This volatile climate is further exacerbated during hurricane season. From June to November, Florida is at risk of being hit by hurricanes, which can bring devastating winds, heavy rainfall, and storm surges. Hurricanes, while posing a significant threat themselves, can also spawn tornadoes as they make landfall or even as they churn offshore. These tornadoes can cause additional damage, compounding the destruction already wrought by the hurricane's winds and rain. The outer rain bands of these powerful storms often contain rotating thunderstorms capable of producing tornadoes, adding yet another layer of complexity to Florida's tornado risk. These rain bands can extend hundreds of miles from the hurricane's center, meaning that even areas not directly in the path of the storm can experience severe weather. Beyond hurricanes and thunderstorms, Florida's unique ecosystems, such as the Everglades, also play a role in its weather patterns. The vast wetlands can influence local weather by adding moisture to the air, which can contribute to the development of afternoon thunderstorms. Meteorologists in Florida are constantly monitoring these complex interactions to provide accurate weather forecasts. The state's volatile climate requires advanced technology and expertise to predict and prepare for severe weather events. Communities across Florida have become adept at preparing for these weather events. From boarding up windows to stocking up on supplies, Floridians know the importance of being ready for whatever Mother Nature throws their way. During severe weather events, shelters provide a safe haven for residents, and emergency responders work tirelessly to ensure the safety and well-being of the community. The resilience and preparedness of Floridians are key to weathering the storms that frequently impact the state. Despite the challenges posed by its volatile climate, Florida remains a beloved destination for tourists and a cherished home for its residents. The state's natural beauty and vibrant culture continue to shine, even in the face of unpredictable weather. Florida's weather, while unpredictable, is an integral part of what makes the state unique. The interplay between land and sea, the dramatic weather patterns, and the resilience of its people all contribute to the rich tapestry that is Florida's volatile climate. Section 5. The Perfect Storm Understanding Tornado Formation. Tornadoes are nature's most violent storms, capable of unleashing incredible power in a concentrated area. These swirling columns of air can cause widespread devastation, tearing through buildings, uprooting trees, and hurling debris with terrifying force. Their unpredictability and sheer strength make them one of the most feared natural phenomena on Earth. Understanding how these meteorological monsters form is crucial for appreciating the threat they pose, especially in a state like Florida, with its unique set of contributing factors. Florida's geographical location and climate make it particularly susceptible to tornadoes, especially during certain times of the year when conditions are just right. Meteorologists and scientists dedicate countless hours to studying these storms, analyzing weather data, and tracking tornado paths to better predict and understand their behavior. Tornado formation requires a specific set of atmospheric conditions to align, a perfect storm of ingredients, if you will. These conditions include the presence of a thunderstorm, which provides the necessary energy and moisture. The storm clouds gather, creating a dramatic and often ominous sky, signaling the potential for severe weather. It all starts with warm, moist air near the ground, topped by a layer of cooler, drier air aloft. This combination creates an environment ripe for instability. On a sunny day, the ground heats up, causing the warm air to rise. As this warm air ascends, it encounters the cooler air above, leading to the development of strong updrafts. This creates an unstable atmosphere, much like a pot of boiling water about to bubble over. The rising warm air and descending cool air create a turbulent environment, with storm clouds building up and dramatic weather changes occurring rapidly. This instability is a key ingredient in the formation of tornadoes. As the warm air rises, it can begin to rotate if wind speed and direction change with height, a phenomenon known as wind shear. Wind shear is a critical factor in tornado formation, as it provides the necessary rotation for the storm. Meteorologists measure wind speed and direction at different altitudes to assess the potential for tornado development. This rotation, often visible as a spinning cloud base called a wall cloud, is the precursor to a tornado. The wall cloud is a telltale sign that a tornado may be imminent. Storm chasers and meteorologists closely monitor these formations, as they can provide valuable clues about the storm's behavior and potential path. As the rotating updraft intensifies, it can stretch downward, eventually forming a funnel cloud that touches the ground, at which point it's classified as a tornado. The funnel cloud is the visible manifestation of the tornado's power, and once it makes contact with the ground, it can cause significant damage. Understanding the process of tornado formation helps us better prepare for and respond to these powerful storms, ultimately saving lives and reducing the impact of their destruction.